lecture will cover some of the details that you'll need to write a results section. So your results section should cover kind of the main ideas that you have described in your introduction. And your narration should be clear enough that the reader doesn't need to get the numbers to get the main point across. Now, your results section will also include the numbers, but you also need to include that narration so your reader can understand them. You want to orient all of the results you're discussing in terms of how it relates to your research questions, how the variables are related, and the best way to do this is to kind of mirror the order from the introduction. So in your introduction, hopefully you presented several hypotheses, and so as you're describing your results, you want to come back to how your results support or don't support your hypotheses. So results are about numbers, but also about putting those findings into words. So to be sure that you understand the findings, as you run your analyses, make sure to keep track of the relationships between your variables that you're finding. So you will do this in your analyses assignment. So you're going to submit your SPSS output with kind of your annotations describing what this tells you about the variables you're interested in. Now, when you're writing your results section, your reader is not going to see your output, but you want to make sure that they understand it, they have the information they need from the output, but also understand it in terms of how the variables are related. So you want to describe your findings in terms of your research questions. You will also need to create tables or figures, at least one of them, to kind of reveal the relationships that you want to focus on. You're not going to do that this week. That's going to be for next week, but it's important to start thinking about it right now. So what goes into the results section? The results section is supposed to be a summary of the data and statistical analyses that you have conducted. So it should begin immediately following the method section. You don't have a page break. You don't start on a new page. It comes right after the method section. And it provides complete and unbiased reporting of the findings, just the facts. You need to describe the facts in terms of your research questions, but you're not doing a lot of discussion or any discussion. So you're not talking about why you found the results or what the implications are. You're just saying, there was a significant difference between these two groups and this group was higher, or there was a correlation between these variables and as this variable increased, the other decreased. So you're describing the relationship between your variables, but not discussing it, because that will go in your discussion section. What your results section actually looks like will vary based on the types of analyses. So I'm going to try to go through and give you an idea of what those results should look like for each of the three kind of most likely types of analyses that you may do. So we're going to start with a Pearson correlation. Most people who are using correlations in their final project may be looking at multiple correlations, right? So you're not necessarily just interested in the correlation between one set of variables. There might be multiple sets. So you'll need to do this. So in terms of what should actually go into the Pearson correlation results section, the very first thing you want to identify is the type of test being conducted, a Pearson correlation in this case. You're going to report the correlation results between each of the variables discussed in the hypotheses and measure section. So almost all of you will probably run some kind of correlation so that you can talk more generally about the relationships between the variables you're studying. When you're reporting the correlation, it's important to include the directionality. So don't just say there was a significant correlation, but was it positive or negative? And also explain this. So you need to explain it in terms of the variable. Higher score on X means a lower score on Y. And you want to be careful to not use causal language in a correlation. We've talked about the fact that correlations do not mean causation. So several of you have projects like this where you might be interested in correlations between multiple pairs of variables. So you're running more than one correlation. So for example, maybe we're asking, do more mature students study more than younger students? And we're looking at the amount of learning techniques or the number of learning techniques they're using, the age, and the amount of study time. And so if we're interested in kind of all three of these variables, we would look at the correlations between each set. So we're going to look at the correlation between age and the number of learning techniques people use. We're going to look at the correlation between age and study time, and also look at the correlation between learning techniques and study time. So that means we're going to need to report on 3 different correlations because there's 3 different possible pairs here. So this is generally what a correlation section would look like. Result section. So we're going to start by identifying the type of test. Pearson correlations were computed to see if there was a linear association between the variables in the study. In this sample, older students tended to report studying longer. So you can see that we've noted the direction, right? Older students studied longer. You can see that we have reported the correlation results. So in terms of the results that you report for a correlation, you've got R, which is your Pearson coefficient, and you've got your p-value. Note that there's spaces before and after each equal sign, and you do the same thing for greater than and less than signs as well, space before and after it. And note that our statistics, R and P, are italicized. Remember that we're doing this for each one of the correlations we tested, so we're going to go on. However, there was no relationship between age and using more learning techniques, and we've reported on that non-significant correlation. We've still reported the correlation coefficient and the p-value, which is greater than 0.05 and therefore not significant. And then we report on our last finding. Participants who spent more time studying also reported using more learning techniques. So we've got another positive correlation there. And again, we've reported our R value and our P value. Okay, so next we're going to talk about independent samples tests. So t-tests. So these would be if you are comparing 2 different groups. Parents versus non-parents, men versus women. Most of you aren't doing actual true experiments, but you still may be lumping your participants into 2 groups and comparing them. And you have one dependent variable that everyone reported. So parents and non-parents reported on stress. We're comparing the differences in stress. A few people might need to use a repeated measures t-test. And I didn't describe these separately, but the way you report it would be very similar to this. You just want to make sure that you're describing the comparisons correctly. So if you're doing a repeated measures, or SPSS calls it a paired samples t-test, you're comparing the same people on the same measure under different circumstances. So maybe we have people report on their grades in online classes versus their grades in in-person classes. Everyone reports in both contexts, and the outcome is the same, grades, but we're looking at grades when people are online and grades when people are in person. Or maybe we have a measure of anxiety and we've got people reporting on their anxiety in the morning and their anxiety in the evening. Same group of people reporting on the same variable in 2 different contexts. So that would be paired samples if you have the same people in both groups. Okay, so in terms of what goes into a t-test results section, you're going to start by identifying the test being calculated. So an independent samples t-test or a paired samples t-test. You're going to include the mean and standard deviation of the variables. Technically, this can go either in the text or in a table, but I would like to see it in your text, even if you also include it in a table. Next, you're going to report the test results in APA style, making sure to include an effect size. And you also want to report the direction of the difference if one is found. So make sure here, just like in your correlation results section, that you include the numbers. Particularly the mean and standard deviation are necessary to help understand kind of how the groups are related and how big those differences are. You want to make sure to include that direction of the difference. If there was a significant effect. So which group was bigger or smaller? Because again, this is really essential to your reader understanding the meaning of these results. Okay, so again, we start with our results section, and so we're going to start by identifying the tests. An independent samples t-test was computed to see if learning to write about research improved understanding and memory. Okay, so we're going to include our t-test results. So we've got a t with 98 degrees of freedom equals 6.78, and we've got our p-value there. We've got our effect size, Cohen's d in this case. We have the mean and standard deviation for the experimental group. So on average, students in the experimental group, we put the means. Learned more from is where we're telling about the direction of the difference. So experimental group was higher. We learned more from the article than students in the control group. And so now we've got the mean and standard deviation for the other group. Note that we've got the statistics are italicized again, so T and P and D, mean and standard deviation are also italicized and capitalized. Okay, so this is a counter example if you did not find significant results, but you'll note that we report the same things. We're still identifying the test. We're still giving the t-test results. And again, here we can see that the p equals 0.078, which is bigger than 0.05, so it is not significant. We're still giving the effect size. We're still giving the mean and standard deviation for the experimental group. In this case, the direction of the difference is there was no difference, right? So did not learn more. And then we've got the mean and standard deviation from the control group. Just some specific notes on formatting your statistics. So in this format, the statistics are part of the sentence, but you put a comma before you start reporting on them. You need to make sure to include your degrees of freedom with your t-value. Again, note that there are spaces before and after the equal sign and the greater than or less than. There is no space before the degrees of freedom, so that kind of goes with the t-value, or with the letter T with a statistic. You've got your p-value, and again, you want to report that specific p-value unless the p-value is smaller than 0.001. But if it's anything greater than 0.001, you report p equals and the specific p-value, and you also report Cohen's d effect size. Finally, we're going to talk about ANOVA. So remember that for an ANOVA, and this is true whether it's repeated measures or independent groups, we've got more than two groups that have all reported on the same outcome, and we are comparing them. So if you have 3 or more groups, you'll want to do an ANOVA. We are going to talk, the example is going to be an independent groups ANOVA, but it would look similar if you were doing repeated measures. So just like for an ANOVA, the results section is going to include the same basic things. We're going to identify the type of test being calculated. In this case, our example is going to be a univariate ANOVA, meaning there's only one independent variable. Now with the ANOVA, it's a little different because remember, we will have that overall test to see if there's a difference between our groups somewhere. If we retain our null hypothesis for our overall ANOVA, all we have to report is that overall test. But if we reject our null hypothesis and determine that there is some group difference in our overall ANOVA test, then we would also report on the post hoc tests and the effect sizes if available. You want to make sure to include the mean and standard deviation of each of your groups and then report on the direction of the differences. Okay, so here's an example. We want to know, does knowing about research methods make you feel smart? So we've got our participants. This is an independent groups one. So we have split our participants into 3 groups. One group watches an educational video about raccoons. One watches a 2-minute video about research methods. And a third group watches a 10-minute video about research methods. And after each of their videos, all of the groups report on how smart they feel on a 5-point Likert scale. So 3 different groups, 3 different experiences, but everyone is reporting on that same dependent variable. Okay, so 2 parts to reporting on ANOVA. Part 1 is reporting on those overall results. So remember that with an ANOVA, we start with the F-test, which tells us, is there a difference anywhere between the groups? It doesn't matter which part or which pair of comparisons we're doing, that overall tells us, is there differences anywhere? So the overall test results will be the F-test. So we would get something like this. We're not going to worry too much about the specific data since this is really about how to report the results. And so I'm going to assume you've got the results. So when we get our results, the things that we want to report on for the overall test is that F and the degrees of freedom associated with it. Sometimes we also report on the mean square error. We, of course, want to report on the p-value associated with the F, and then partial eta squared is that last one, which is a measure of effect size. So it might look something like this. We're going to start by identifying the analysis. A univariate analysis of variance, or ANOVA, was conducted to investigate differences across the different groups. Okay, is there any difference anywhere? Is what that overall ANOVA is for. Then we're going to report on the conclusion for the overall ANOVA. Overall, watching videos about research methods made students feel more intelligent. Note that it doesn't say which groups were different because we don't know with just that overall test. We just know that there was some difference there. And then we're going to report on our overall ANOVA results. So we've got our F-test and our mean square error, and then our p-value is less than 0.01, and we've got that partial eta squared. So if you have an overall effect, if your F-test is significant, then you're going to proceed to part 2 and do a post hoc test to see which groups are different from each other. Before we cover that, though, we're going to cover how to report on a non-significant F-test. Okay, so this is our counter argument. What does it look like when we have a non-significant F-test? We're going to start the same way. Identify our analysis. An ANOVA was conducted to investigate differences across different groups. We're going to report our overall conclusion. Watching videos about research methods did not make participants feel more intelligent. And so we have our F results here. Our P is greater than 0.3, which is why we know it's non-significant, but we've still reported all of the important components with our F and our degrees of freedom, MSE, and p-value, and all that stuff is still in there. So if you have non-significant results, if your F-test is non-significant, you're going to stop here. What this tells you is there were no other group differences if you don't have a significant overall effect. Okay, so if your p-value for your F is non-significant, we're going to stop. No more post hoc tests. However, if you did find that overall test, then you need to go on to part 2 of ANOVA analyses, which is reporting that post hoc group comparison. And again, this is only if your overall F-test was significant. Okay, so remember that this is our data. Remember that these overall F-tests just tells you if there's a significant difference somewhere in some pair of these comparisons, in some pair of these groups. Post hoc test results compare every possible pair of conditions to tell you which pairs are significant. So you might get something like this, where the raccoon is different from the 2-minute video. The raccoon video is significantly different from the 2-minute video. And the raccoon video is definitely also significantly different from the 10-minute video. But there is no significant difference between the 2-minute video and the 10-minute video. So you can kind of see this pattern where we feel smarter after watching any kind of educational video about research methods, but there's no difference in how long, like the amount of time the video is, doesn't matter. Okay, so this is what this would look like. Our first comparison between the raccoon video and the 2-minute video was significant. So we have a significant difference there. So when we write it up, we need to add to our reporting of the overall test. So this next step is, in addition to reporting of the overall tests, you report on that F-test and then you add more sentences. So we're going to identify the post hoc analysis that we did. Remember that there are multiple post hoc analyses you might use, so be sure to report which one you used. You want to be sure to include the mean and standard deviations for each of your groups. And then you're going to use your Tukey numbers here, not another t-test, but you're going to use those numbers from your post hoc test to report on the Tukeys, t, degrees of freedom, the value, your p-value, and your effect size for that post hoc test. So this is the first one. The final two comparisons, remember that we have a significant difference between the raccoon video and the 10 minutes, but there's no significant difference between 2 and 10 minutes. So we need to report on each one of the comparisons. So next I'm going to report on my second significant difference. So watching the 10-minute video made students feel more intelligent than watching the raccoon video. I've got, again, my Tukey's t-test results with my p-value and my effect size. Note that I only had to report on the mean for the 10-minute video because I already reported on the mean and standard deviation for the raccoon video in my previous sentence. So I've reported my two significant comparisons. I also need to report on my non-significant comparisons. So something like watching a 10-minute video did not make participants feel more intelligent than those who watched a 2-minute video. And I've just reported that my p-value was greater than 0.05. So that is kind of the quick rundown on how to write a results section for each of the kind of most common types of analyses you might be using in your paper.